Imagine your brain is a huge orchestra. Picture a grand concert hall filled with musicians, each one playing a unique instrument. The conductor stands at the front, guiding the symphony with precise movements. This is your brain, a complex and harmonious ensemble. Billions of tiny musicians called neurons work together. These neurons are the individual players in this grand orchestra, each contributing to the overall performance. They communicate with each other through electrical impulses, creating a symphony of thought. Each neuron sends electrical signals, like musical notes. These signals travel through the intricate network of the brain, much like how music flows through the air. The timing and rhythm of these signals are crucial, as they determine the harmony and melody of our thoughts. Together they create thoughts, feelings, and actions. Just as a symphony evokes emotions and tells a story, the coordinated activity of neurons results in our experiences, memories, and behaviors. This orchestration is what makes us who we are. This hidden world inside your head is a mystery we're just starting to understand. Despite centuries of study, the brain remains one of the most enigmatic organs. Scientists are continually uncovering new insights into how this complex system operates. Scientists have tried hard to understand how the brain talks. They have developed various methods and technologies to decode the language of neurons. From early anatomical studies to modern neuroimaging techniques, each step has brought us closer to understanding the brain's symphony. Old ways of looking at the brain were like listening to an orchestra from far away. We could hear the music, but the details were lost. The nuances of each instrument and the subtle interactions between them were beyond our grasp. We knew the neurons were talking, but we couldn't hear what they were saying. The signals were there, but our tools were not refined enough to capture the full complexity of their communication. It was like trying to understand a conversation in a noisy room. Then came microfluidics, a new technology that's changing everything. Microfluidics allows us to study the brain at an unprecedented level of detail. By manipulating tiny amounts of fluids, we can observe the behavior of individual neurons and their interactions. It's like shrinking down to the size of an ant and walking among the neurons. This perspective gives us a new understanding of the brain's inner workings. We can see how neurons connect and communicate, revealing the intricate dance that underlies our thoughts and actions. We can see how the brain works up close. This newfound clarity is revolutionizing neuroscience. With each discovery, we get closer to unraveling the mysteries of the mind, bringing us one step closer to understanding the true symphony of thought. Sometimes small things make a big difference in science. In the vast world of scientific research, it's often the tiniest innovations that lead to the most groundbreaking discoveries. These small advancements can open up new avenues of understanding and pave the way for future technologies. Hakuba Murota and his team in Tokyo made a tiny chip, smaller than a penny. This chip, though minuscule in size, holds the potential to revolutionize how we study the brain. The dedication and precision of Murota's team have culminated in a device that could change neuroscience forever. This chip can study single neurons. Neurons, the fundamental units of the brain, are incredibly complex and delicate. By focusing on individual neurons, scientists can gain insights into their behavior, interactions, and responses to various stimuli. This level of detail was previously unattainable with traditional methods. It's made of soft silicone and has tiny channels like microscopic pipes. These channels are meticulously designed to mimic the natural environment of neurons, providing them with the necessary conditions to thrive and function as they would inside the brain. These channels are so small they can control the flow of liquids and even single cells. This precise control allows researchers to manipulate the environment around the neurons, introducing various chemicals or stimuli to observe their effects in real time. Neurons on the chip stay alive and healthy. Maintaining the health of neurons outside the body is a significant challenge, but this chip provides a stable and nurturing environment, ensuring that the neurons remain viable for extended periods. Scientists can watch how they act in new ways. By observing neurons in this controlled setting, researchers can study their activity patterns, communication methods, and responses to different conditions, leading to a deeper understanding of brain function. The chip is like a tiny home for neurons, giving them everything they need. This miniature habitat replicates the brain's environment, providing neurons with the nutrients and support they require to function optimally. This helps scientists study these delicate cells. With this innovative chip, researchers can delve into the intricacies of neuronal behavior, paving the way for new treatments and therapies for neurological disorders. The future of brain research looks promising thanks to these tiny yet powerful tools. And with this amazing chip, Murota's team could listen to neurons talking. This microfluidic chip, a marvel of modern technology, allowed scientists to eavesdrop on the intricate conversations happening within the brain. Imagine being able to hear the whispers of neurons as they communicate, sharing vital information that keeps our minds functioning. They saw which neurons talk to each other, mapping out the complex web of connections that form the basis of our thoughts and actions. This visualization was like watching a bustling city from above, where each neuron was a building, and the connections were the roads and highways linking them together. How often and what they said. The frequency and content of these neuronal conversations revealed patterns and rhythms, much like the beats and melodies in a piece of music. By understanding these patterns, scientists could decode the language of the brain. They called these talking groups neuronal ensembles. These ensembles are like small communities within the brain, each with its own unique role and function. Just as a choir has different sections for sopranos, altos, tenors, and basses, the brain has different ensembles for various tasks. It's like small groups of musicians playing a melody within the bigger orchestra. Each ensemble contributes to the overall harmony, creating a symphony of thought and action. The brain, much like an orchestra, relies on the precise timing and coordination of its parts to function smoothly. These ensembles help the brain think and make decisions. They are crucial for processing information, solving problems, and making choices. By studying these ensembles, scientists can gain insights into how we learn, remember, and even how we experience emotions. But they discovered even more. The research revealed that these neuronal ensembles are not static. They can change and adapt over time. This plasticity is what allows the brain to learn new things and recover from injuries. They figured out each neuron's job in the network by watching these ensembles. By observing how neurons interact within these groups, scientists could determine the specific roles of individual neurons, much like identifying the instruments in an orchestra and understanding their contribution to the overall performance. This knowledge opens up new possibilities for treating neurological disorders and enhancing brain function. Murota's chip wasn't just for listening, it could also make neurons do things. It's like tapping a musician and saying, "Play that note again." By doing this, they saw how these signals moved through the brain. They learned how neurons talk to each other. This helps us understand how the brain works. This also helps us think about fixing problems in the brain, like rewiring a broken circuit. Many brain problems, like Alzheimer's, Parkinson's, and epilepsy, happen when neurons can't talk well. This chip helps us study these problems and find new treatments. By growing sick neurons on the chip, scientists can see how they're different from healthy ones. They can then test new medicines on the chip. This is much better than testing on animals, which isn't always the same as human disease. Section 6. Building better brains. Learning about the brain can also help us build smarter computers. Imagine computers that learn and solve problems like our brains. By studying how the brain is wired, we can make better computer programs. This could lead to super smart computers that can do amazing things. Section 7. The future of artificial intelligence. Imagine doctors that are computers, self-driving cars, and robots that help us at home and work. This is what brain-inspired computing can do. By studying how the brain learns and changes, we can make smarter, more human-like computers. This can change everything from healthcare to how things are made. Section 8. The uncharted territories of the mind. The brain is still a big mystery, but tools like microfluidics help us understand it. As we learn more, we'll discover amazing things about what it means to be human. Exploring the brain is like exploring ourselves. Section 9. The orchestra plays on. The neurons in your head are always playing their symphony. Every new discovery helps us understand the music of the mind. The future of brain science, biotechnology, and artificial intelligence is exciting. As we explore the brain, we'll find amazing things that will change the world.